Alright, so now we should have a talk by Ben. We should talk about caching. The problem is that Ben couldn't make it, so he recorded a video for us. So it's kind of too bad, but I mean the video is pretty nice. We're just gonna play the video. Yeah. Can you play more of those? The sound noise or something. Can we?
Make it to Merv camp. So instead I brought you this video. Okay, so hello to everyone at Merv camp and everyone out there on the internet as well. I couldn't actually make it to Merv camp, so instead I brought you this video talking about the new merb-cache library. This video is actually intended to be a companion piece to a tutorial I wrote for Merv-unity. Here's a link if you happen to miss it. It's a pretty in-depth overview of the design ideas and goals of the new merb-cache. I've been getting some pretty good feedback and responses from it. A lot of people are asking, how do we actually use the new merb-cache in our applications? So the goal of this video is to show you how to do that. All the code you're going to see in the screencast is part of the Community Shelf project. It's a simple application for managing and tracking a personal bookshelf or a bookshelf for an office. The code's up on GitHub. This is the link. It's written in Data Mapper, Merb, and uses the new merb-cache system. So it's a great way to get up and running with the new merb-cache. So we're going to dive right in and look at how to configure the new merb-cache. So all of our configuration is going to be handled in the environment files, in this case development.rb, because we're using the development environment. And if you look down at the bottom here, we've got our merb-cache setup block. And it's broken up into 3 chunks. The first 3 lines are for registering our fundamental stores. The next 2 are for our strategy stores. And the last line registers our default store. So for our fundamental stores, we typically give it a store name that we want to register, the store type or class, and then a options hash for any configuration values that we need to pass to our store. You can see these first 2 lines create 2 separate file stores. One's caching to the fragments directory, the other one to the actions directory. The third line creates a memcache store and registers it with a localhost server. Next 2 lines register our strategy stores, the action store and the page store. That's going to handle our action and page caching. It looks like the action store is going to cache into the action file store, which will store it under temp/actions, and likewise the page store will be caching to memcache. The final line is registering the default store, and the default store is going to be used by our caching system whenever we don't supply the name of the store that we want to use. Using this array access method off the ad hoc store allows us to define the precedence we want to order our stores in. So whenever we make a caching request, it's first going to attempt to cache to the page store, and if that fails, it's going to try the action store, and finally the fragment store. Normally you'd have to scope these store names with the merb-cache namespace. The reason we don't have to here is because we're using the merb-cache simple setup plugin in our init file, and that's going to allow us to shorten the names of these stores in our configuration. So we're almost ready to fire up the app, but first we need to get into a default state, and we're going to use a few rake tasks to do that. The first one is rake merb cache clear, and that's going to go ahead and clear all the cache entries for us if you happen to have any. After that, we're going to run rake dm db generate, and that's going to generate some random data in our database so that we have something to cache. You can see the SQL being generated right here. The way that works is it's using dm sweatshop to generate some test models. That's being done in our generate.rake file. Looking at these lines, it's a pretty simple syntax, and those fixtures are defined in our spec/fixtures file. dm sweatshop has a pretty simple DSL for defining fixtures, and it lets you define some pretty complex associations between your fixtures. Back in our generate.rake file, you can see that we're generating over 1,500 unique models in our database, and that's awesome. Okay, we're going to fast forward a little bit so that our rake task finishes. So now we're ready to fire up our Merv app. Let it boot up. So let's take a look at that in the browser. So this is the main page of Community Shelf, and what you got is 4 main parts. Up at the top here, on the left side, there's a list of recently added books. Then there's the login and browse books and add new books buttons to the right. And down at the bottom there's a overdue books list and a recent activity list. And this index page is the first page that we want to cache. So before we do that, we're going to need to get a baseline of this page to see what we're working with. Let's just quickly go over the output that was logged just to get a ballpark estimate on where we're at. Down at the bottom here we see the dispatch time was pretty close to a half second, which is pretty bad. And it looks like the reason was a bunch of these SQL statements that were fired off. Looks like we could have an n+1 query problem or something. So it looks like caching this page could help out a lot. Let's use the Apache benchmark tool to run our baseline. We're going to do 50 requests. Okay, so we fast forward a bit. The test really took 21 seconds to finish. And it's showing that we were averaging about 2.38 requests per second, which is not very good. And we stayed pretty close to that half-second time for request. Back in our log, you can see all the requests and all the SQL statements. So let's start by fragment caching the different sections on the main page. It looks like we're going to be able to cache 3 out of the 4 sections: the recently added books, the overdue books, and the recent activity. It is possible to cache this toolbar to the right, but when users log in, it's going to end up showing different data for each user because it's going to be displaying their usernames. So it's going to be a little more difficult to fragment cache the toolbar. And a lot of these SQL statements are coming from these other 3 sections, so we're going to worry about them for now. So let's switch back to TextMate and open up the index view of the dash controller. And we see that we've got 4 partials that we're calling, which pretty much correspond to those different sections to be outlined. We're going to use the fetch partial method instead of just the plain old partial method. It's pretty much the same thing, except it'll cache it after it renders it, and on the next request, if it matches the entry in the cache, it'll serve that instead of re-rendering the partial. We're also going to add an updated at parameter. It's going to be the latest books updated at timestamp, or just nil. And what that's doing is any parameters that are passed to the fetch partial are going to be passed through to the partial, but also they're going to go into the key calculation for the cache entry. So when we cache this recently added partial, part of the key is going to be based on the timestamp that the latest book was updated at. So whenever we update a new book or create a new book, that timestamp is going to change, and that's going to cause a new cache key to be calculated, which will cause the stale content to be replaced with the newest, freshest content. That rescue nil at the end here, that's just a safeguard in case there's no books in the database and book.latest returns nil and nil.updatedAt throws a no method exception. And we're going to do the same thing for each of these methods as well, with their respective models. And that's really all we have to do to fragment cache these. We don't have to add any expiring logic to our controllers or elsewhere in our application. Because these updated at parameters are going to be part of the key calculation, it's going to have the same effect for us, and it's going to keep our controllers and app code very clean. So let's take a look at that in the browser. And see if we notice any time difference when we refresh. Go ahead and clear our console real quick. So you can see down at the bottom, not much of a time difference, which makes sense. This was the first request. Go ahead and hit it again, and we notice that it's taken about 0.02 seconds instead of about a half second. So it's gone down by about an order of a magnitude in the time it takes to render one of these pages. And looks like we've reduced the number of SQL queries to just 3 queries, which are updated at queries, and that's the reason for the big time gain. Let's go ahead and benchmark this with the Apache benchmark tool. Okay, so that one finished much quicker, and it's showing about 25.41 requests per second, which is an order of magnitude faster, which means that fragment caching gave us a performance increase, but I think we can do better. Before we move on to action caching, let's take a look at the cache entries that were generated from these fragment caches. Taking a look at our development.rb where we set up our caches, looks like the fragments are being cached to the temp/fragments folder, and we see a bunch of subdirs. We see these 3 folders here with a couple of cache entries in them. So taking a look at the master feed, the activities cache entry. So what we see is the cache entry for the master feed partial, and it looks like the key is the partial name, and it's got looks like a digest tacked on the end, and that SHA-2 digest was generated from our updated at timestamp. So if we were to somehow cause the activity feed to change or to update it, we can do that by logging in to our application, and we're going to use OpenID for that. And go ahead and register. So if we scroll down to the bottom, we can see the activity feed has been updated. It's added an activity for my account that's been created. So let's go back to TextMate and see if there's any new entries in our cache. And it looks like we got one new entry in the master feed partial, and you can see the new content that's been cached. So the old cache entry hasn't been deleted, which is a problem, but it's a pretty easy problem to fix. It's not hard to go through and clean up old files, or if you're using something like merb-cache, merb-cache will take care of this for you, so you don't even have to worry about it. If we take a look at the console again, it looks like the dispatch time is about 0.16 seconds. So that's better than the 0.4 something seconds we were seeing earlier, but it's still not very good. The good news is that only happens when an activity is updated. And in just a little bit, we're going to show you how you can get rid of even this using hot caching. So on to action caching. So one of the big advantages of merb-cache is that you no longer have to specify action or page caching. You just specify that you want to cache an action, and depending on your cache setup, merb-cache will figure out the fastest way it can cache a request and cache it that way. So if we take a look at our dash controller, which is serving up the page that we've added fragment caching to, we can action cache this index action by calling the cache action and supplying the action name. We're also going to add a condition and this acts just like before or after filter condition. This is saying that you should cache the index unless the user is authenticated. And this authenticated method is going to check and see if the user is actually authenticated. So what does this do? Well, back on our index page, after we log in, we show the user's username on the toolbar on the right side of the page. So what that means is that every user's page is going to be different, because each different user's page is going to have their username in it. The only pages that are going to be the same are for users that aren't authenticated or haven't registered yet, which means that we can't actually page cache this action because we actually have to hit merb to ask if the user is authenticated, which means that the fastest way to cache this action is to action cache it. merb-cache is going to see that condition, that unless authenticated, and the page cache is going to know that it can't cache that because of that condition, because that requires hitting the actual merb process. So it's going to return nil. It's going to say that I'm not able to cache it. merb-cache is going to go down the line and try the action cache store after that, and the action cache store is going to know that it can cache that request, so it's going to go ahead and do it. And again, this only works with an unauthenticated user. So let's fire up our browser, but first let's clear the console. Go ahead and log out and take a look at the console. And so we can see the action time and the dispatch time. It's pretty much the same, even though we were logged out for that last request. But that's what's expected because that was the first request. Hopefully this next request will be much faster. And it looks like it was. Instead of taking 0.02 seconds, it's taking 0.008 seconds, which is another order of magnitude improvement. And if we go over to our baseline test and run it again, we see that we're now getting 123.02 requests per second. So we've gone from 2 requests per second to 25 requests per second to 123 requests per second, which is pretty nice. Alright, so let's move on to hot caching. The basic idea of hot caching is that in the past when we would call an action that would cause our cache entries to be stale, in the past we would expire those cache entries, but now we're going to regenerate the data that should be in those entries and just push them in their place. So back in TextMate, let's take a look at the books controller. This is the controller where you do your CRUD operations on the book model. You can see here we have the create action, and the create action is going to add books to our book list So what we can do here is eager cache our book list, hot cache it whenever we create a new book. And that's done using the eager cache method. We give it the name of the action that we want to eager cache after, the action, or in this case the controller, in action, because our controller is a separate class than books, in this case dash, and we give it the store that we want to use. The reason for this is that with just this information, this request could be page cached, but we don't want that to happen because in our application we're specifically action caching that page because of the content displaying the user. We can return a hash or a mash, and we'll use that as the environmental hash. Another option is to actually create an instance of a controller, and that controller instance will be used. But in this case, we want to return a request object using two helper methods that we have available. This is probably going to end up being the most common use of eager cache. The first helper method is build request, and that's going to accept a path and some optional parameters. The path is also optional. In our case, we don't need to pass it any parameters because we're just making a request to the main dashboard page. So we're going to use the second helper method called build URL and give it the dash named path. And it's going to work just like the URL method in our controllers. So let's test this out in our application. We need to add a book. We're going to need to log in before we can do that. This is using the ISBN-DB web service to fill in all this information for us. So before we actually create that book, let's go ahead and clear the console and our logger. Okay, so we got a message saying the book had been added. Let's take a look at our logger. Up a little further, we can see the time for the request to actually create this new book. Took 0.013 seconds. And you'll notice that takes less time than the time to actually render the book list on the front page. So after this request was served, we've got a bunch of SQL statements happening after. The reason they're happening after is because the eager cache method is using a run later method, which puts this hot caching request in the worker queue so that it actually happens after the response has been served to the user, which allows us to quickly respond to the user without having to make them wait for the SQL and rendering time of the item we want to hot cache. So let's go back to our index and notice that was pretty snappy. Looks like it took 0.02 seconds for that response, so that's exactly what we wanted to see. And we've got the new pragmatic programmer entry in there along with the entry in our activity feed. So that all looks good. If we go ahead and log out, we see that we got an even faster request time because we were able to action cache that, not just fragment cache it. But that also brings up an important point. One of the main advantages of eager caching and hot caching is that because we've tiered our caches so that we're relying on fragment caching and action caching and also hot caching, whenever our hot cache updates, it's going to cause our fragment cache to expire and then repopulate, so that our different caching layers can all take advantage of hot caching. One last thing I want to show you with hot caching is the ability to pre-populate the next page the user might see. Looking at the books controller, you can see that we're eager caching the index page. We're also caching it, but we're adding a expire in 30 seconds condition to this eager cache statement. Now, what that's going to do is it's only going to hold that cache entry for 30 seconds. And what this means is that if we attempt to cache this to the file system, it's going to fail because the file system can't automatically expire files. But something like merb-cache has that expire in built in, so merb-cache will be able to cache these requests. In this case, in our eager cache block, we are grabbing the page parameter from the original request, incrementing it by 1, converting it back to a string, and then sticking it back in the params hash and building the request from that. So that's the effect of that is that when a user goes to page 1 after the user has been sent the response from page 1, it's going to go ahead and cache page 2 for that user for 30 seconds. So this is a quick and easy way to reduce the number of cache misses that we're going to have in our application pretty easily, just by predicting that a user often goes from one page to the next. And that's it for merb-cache. The Community Shelf project is on GitHub with the link provided at the beginning of this video. If you want to see it again, it's github.com/benburkert/community-shelf. All the code's freely available. So if you have any questions on merb-cache or just caching in general, feel free to email me or send me a message on GitHub or just hit me up in the IRC chat room. Thanks for watching.
So I won't be able to take any questions, I'm sorry. But feel free to contact Ben, he's always online anyway. Did you guys thought it was pretty cool or what? So that should be part of Merb stack, just so you guys know. We have a question there. Ryan, can you give the mic to Yehuda?
I just wanted to make a quick comment that what you saw there was pretty much the low-level API of merb-cache, and that when merb-cache is officially part of Merb, there's going to be a pretty good set of defaults on top of that to make it easier to use. So that he basically went through, like, if you were to start now with what merb-cache makes available, here you can make it cache, but he didn't. We haven't yet fully finalized exactly how it's going to work if you want to start a new app and just have caching work. But that is going to happen. So,
Wesley?